Welcome to Modeling One-Step Equations. We're going to be doing two things at once. We're going to model the equations with the pieces that you have, and we are also going to write out the work that you would do for these with pencil paper for when you're not using the pieces anymore. So for homework, you were asked last night to color algebra tiles for red for negative, yellow for positive, and to cut them out so that you would have your own tiles to use in order to follow along with me. So real quick, flip your paper over. We're going to go onto the back where it says key, and we are going to review what the pieces mean. All right, so where it says key, and a reminder, any questions you have, just write them in here. So the little pieces, those are equal to 1. All right, if it is a yellow piece, that's going to be a positive 1. Red piece is going to be negative 1. So, or negative 1. The long rod pieces, those are going to be x or negative x. All right, so either a positive x value or negative x value. And then the big square pieces, which we aren't using this year, or we may use it very little, but just so that you know, those are x squared or negative x squared if you have a red piece. Okay, so there's your key, just in case you forgot from our discussions in class. So let's go back to the front, and we are looking at x plus 3 equals 5. So let's set that up. So we don't know what our x is going to be, so I'm just going to do this. This represents my x, and then I'm going to add 3 positives. So you're going to use 3 yellow pieces, and then that is going to be equal to, so I'll put an equal sign in here, 5 yellow pieces. Okay? So the idea here is that we are, an equal sign means that our two sides are going to be balanced. So this 5 is the same as 3 plus some mystery amount. Okay? Now you've probably determined what the answer is already, but that's okay. Let's see how we would model it. So you probably learned in elementary school, they gave you problems that had like a box, and it said blank plus 3 equals 5. And you said you had to determine what the math fact was. We're doing the same thing. You were doing algebra in first grade and you didn't even know it. We're going to do the same thing. We're just using a variable instead. And they probably told you, what did they tell you to do if you didn't know what this was? They told you to do the opposite operation. They said work backwards, subtract. So we're going to do that same thing here. Our goal is to isolate our x value. So I'm going to get rid of it by taking away 3 here and taking away 3 here. So I've taken away 3 on each side, and I have to do the same thing to each side so that they stay balanced and they stay equal. So I'm going to write it over here as minus 3, minus 3. This gives me 0 plus x on this side, and I'm left with 2 on this side. So very simply, I can say that x equals 2. Now, if I want to check my work, I can take that 2 and I can plug it back in for x and ask myself, is 2 plus 3 equal to 5? All right, well, I'm going to reset this up. So there's my 3, or I put those back, there's my 3, and then I'm going to put in my 2 for the x, and so now I'm going to remove my x because we're saying it's 2, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yep, 5 equals 5. I'm good to go. So for you, hopefully you followed along and used your pieces, but if not, we can draw this and say a rod plus 3 equals 5. All right, and from there, we take pieces away. Okay, let's take a look at our next problem. This one says negative 7 plus a equals negative 13. So I'm going to flip my pieces over for me, and for you, you're going to use your red pieces. So have 7 red pieces, and I'm adding to it something. I don't know if it's negative or positive yet. I'm guessing it's probably going to be negative, but I don't necessarily know yet. So it doesn't matter which side you use. If you definitely know it's negative, then you can use your red side. If you're unsure, you can use either side. And then on the other side here, I'm going to put 13 reds. So there's 3, 6, 9, and I have just enough, 13. Oops. There we go. All right, so I have 13 red pieces over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So I need to have the same thing on both sides, and I need to isolate my variable. I need to get this piece by itself. I see that they're all the same color. That makes it so easy to do. So there's a couple things I could do. I have options. One option is I could take away 7 reds from this side. That gets me X by itself. And I could take away 7 reds on this side. So that's one option, is to take away the 7 reds. And then I see that my answer is going to be -6. Now another option is I could also zero out. So just like we've got a 0 up on this one up here, all right, by taking away, I could use my yellow pieces to get 0. So I could make my little 0 pairs here. As a reminder, a red and a yellow make 0. So I could make 7 0 pairs on this side, and what I do to one side, I have to do to the other side. And I can make 7 0 pairs on this side as well. I don't think personally I want to use the 0 pairs for this, or use that particular strategy for this problem, but there are some problems where I'm going to have to use the 0 pairs. But since they're all the same color, I'm just going to take them away. So I could either add +7 to both sides, or I can subtract -7. So I'm going to subtract my -7. And here's my other -7. So now I'm going to write it over here, minus -7 minus -7. Okay. So what you should see here is, minus negative, that's kind of weird. We haven't done that in a while. Hopefully you remember the keep, change, change, where we keep the first number, change to addition, and change the sign of the second number. If we do that on one side of our problem, then we need to do that on the other side. Okay? And that's the same thing as making those 0 pairs. So I get 0 plus A equals -13 plus -7, or -13, and I'm taking out 7 negatives, however you want to understand the problem. And I get -5. So therefore, A equals -5. So if I want to check this, I'm going to say, is -7 plus -5 equal to -13? So I'm going to put my 7 back here, put my 7 back here that I had, and I'm going to put 5 negatives here, because that's what we're saying X represents. 4, 5. All right, take away my negative, and I should get 13 on both sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I only put, not -5, -6. So here, I noticed, I'm like, this doesn't make sense. I put down 5. It should be, I have 12 on this side and I have 13 on this side, which means I missed a piece. Should be -6. So I did not correctly do my math fact, but I said, this didn't work. So I went back and said, oh, it should be -7 plus -6 equals -13. All right, I made a mistake, but through checking my work, I found my mistake. All right, my next problem is, I'm going to have 12 on this side. I have G minus 9 equals 12. So this is a little bit more difficult to set up. These are a little harder. 2, 4, 6, 8, 10, 12. Okay, so there's my 12. Now, this says minus 9. We know through the keep, change, change that we can rewrite this as g plus negative 9 equals 12. So I'm really going to put my x, and I'm going to put 9 negatives. So there's 6, 7, 8, 9. And that takes care of my subtraction that's going on here. So minus 9 is the same as adding negative 9. All right, these are equivalent statements to each other. All right, well, now this is a little bit more confusing because I see that I don't have the same color. In the previous problems, I had the same color on both sides, so it was easy to just take things away. Now I have different colors. My goal still remains the same. I still need to get my x value by itself. So how am I going to get rid of negative 9? Well, the only way to get rid of negative 9 is to add positive 9 because I need to make those 0 pairs. So here's a situation where I have to use my 0 pairs. So I'm going to make my 0 pairs. And so I'm going to add 9 yellows because I have negative 9, so I'm adding positive 9. So that is 0. And if I add 9 to one side, then I have to add 9 to the other side. So let me add 9 over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means, wow, this is what G is going to equal. All right, so I have a negative 9 here, so I added 9 here, and I added 9 here. So I should have 12 plus 9, which is going to be 17. So 3, 6, 9, 12, 15, 16, 17, 18, 19, 20, 21. 21. I don't know why I said 17. My brain isn't working today. But I was wrong, but I found my error by doing the problem. So G equals 21. Now I just need to check my work and say, is 21 plus negative 9 equal to 12? All right, well, if I have 21 of something and I add 9 negatives, I'm going to add my 9 negatives to 9 of the positives because they're going to cancel out and make 0. Okay, so those are all, I'm adding them in. Those make 0, so I should have 12 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 left. So G equals 21. Okay? Hopefully you've been using your pieces. Go back and draw it in. All right, I'm not going to take the time to draw it in, but you need to go back and draw it in. Last problem. We have H minus 11 equals negative 8. Again, when we're using the pieces, we're going to have to do that keep, change, change. And remember, keep, change, change is only on one side. All right, it's used to simplify on single sides of the equation. So I'm going to rewrite this as H plus negative 11 equals negative 8. All right, so I'm going to put my variable bar there. I'm going to put negative 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's one side. And then that equals negative 8. 1, 2, 3, 4, 5, 6, 7, 8, 8. Yes. Okay. So, I'm trying to get this variable by itself. However, unlike some of the other problems, these aren't balanced the same way. Yes, the pieces are all the same color, but I have more pieces on this side than I have on this side, which is different than some of our other problems. So how do I get to 0? Because I'm trying to get this piece by itself. I have negative 11. How do I get to 0? Well, I get to 0 by making 11 0 pairs. So I'm going to add on a positive 11 to this side. And then I'm going to add positive 11 to the other side, because what I do to one side of my equation, I have to do the same thing to the other. So I'm going to add on positive 11, and hopefully I have enough pieces. You should have plenty of pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and let me just grab a couple more pieces. 9, 10, and 11. Okay, so these over here all made 0. So I'm going to take them all out of the way. Those all made 0. And then here I had 8 of these made 0, because there were 8 reds, 8 negatives that were there. So 8 of them made 0. But then there were 3 of them that were left over. So therefore, our x is equal to positive 3. All right, well, let's write it out. So I added positive 11, added positive 11, and that gives me h equals positive 3. Well, if I'm just adding 11 and 3, I can see that if I'm just using these tiles, I have 11 yellows and 8 reds. I'm going to have more yellows left over in the end. So if I want to check this, I'm going to say, is 3 plus negative 11 equal to negative 8? All right, well, let me take 3 positive, and let me take 11 negative. So there's 3, 6, 10, 11. Okay, so I have positive 3 plus negative 11. I'm adding them together, so this makes 3 0 pairs. So those make 0, 0, 0, and I should have 8 negatives left. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 negatives left. So yes, it does work. All right, hopefully you got all that. If not, if you have questions, please write them at the bottom so that I can answer your questions in class. If you need to listen to an explanation again, feel free, rewind, go back and listen to it again. And we will go over this a little bit more tomorrow in class, but you should be well prepared for it.